Continue.
We set it up.
Then?
And then I have to eat.
You
lunch.
eat or he eats?
He bought the lunch for me.
Okay, then. Just put aside first, because you know, right?
No, because it's like, it's noodles, and then it's like, the one with the soup, so like, if you leave it out for too long, it'll like turn.
Okay, next time just sort it out, okay?
Yeah, I need access to the.
Next time I expect you to be like, if you have the time, 10 minutes earlier, set up things, get it ready, okay? I always encourage my students, please give yourself 10 minutes to set up your digital equipment. Unless you have some last minute thing. Alright? Because I have something after this, right after this. Alright? And
Okay.
you alright? Good? Okay, good. So I think you can see my this Jamboard, can you?
Yeah.
Okay, good. So how do I write on my Jamboard? Let me see. I'm trying to see how I get my Jamboard to, hold on. Okay, let me write on present tab to meeting. Okay, press. And then share. I'm sharing the Jamboard already, right?
Yep.
Okay, good. Alright, so by the way, can you record this lesson on your side? Because you are the one who hosts this meeting. Can you? Can you?
Hold on.
You just have to answer me whether you can or you cannot. If you cannot, it's fine.
I need to see if I can find the recording button.
Good. So I need to open this. Never mind, I waited.
No, I can't find it.
Never mind, I have waited for you long enough, so we just carry on. Okay, good. So the first question. Okay, which one we are supposed to do first?
Let me go to my drive.
No, it's okay. It's okay. I will just get it here. Looks like I'm supposed to share another thing instead of Jamboard. Stop share. So let me share my whole screen. Okay, can you see my screen? Should be loading.
Yeah.
Yep, good. Can you see the PDF?
Yeah.
Okay, good. This is the one. Okay, if you look at this, the first question, right? First question, it says what? Consider the following 6 numbers. So over here, right, these are the basic concepts. Alright, these are the basic concepts you need to learn before you can do other questions. So number one, I'm going to draw the, can you see, math universe. Okay, so I'm going to draw the math universe. So under this math universe, okay, you have both the rational and then you also have the irrational numbers. Okay?
Yeah.
Have you learned this before? Rational and irrational numbers?
Not really.
Okay, so now we need to talk about what are irrational numbers. So let's look at what are irrational numbers. Okay, irrational numbers are numbers that if you go and use your calculator, can you get your calculator out?
Yeah.
Yep, square root 2, what do you get?
Decimal.
Yep, it's a non is a non-stop decimal number, right?
Yeah.
Yeah, so it's a, can you just tell me what's the value?
1.41
I ask you to continue, right?
4213562.
So it's 1.41 da 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 da, so non-stop, right? So when you have square root 2, you are going to have a non-stop, okay, decimal number. So these are called irrational numbers. All right.
Okay.
Can I give you another example? What about square root 3?
1.73205080.
So do you think this is an irrational number?
Yeah,
Why?
because it's non-stop.
Yes, it's non-stop. Okay, it's non-stop. All right. Okay, it's not only it's non-stop. So can you just let me know what is square root 3 once again?
1.73205080.
Okay, good. So it's 1.7. So okay, another question I want to ask you is non-stop decimal number. Can this decimal number be expressed as a fraction? Can you convert this 1.7 into fraction?
And
Can you use your
I think
calculator?
so.
Use your calculator. No, don't write it down. Just square root 3 and then your calculator is going to give you the decimal number and just use your calculator, convert it to fraction.
No, I can't do that.
Why you cannot? So what your calculator shows you?
It doesn't allow me to change it to a fraction.
Okay, good. So that means, so bear in mind, if it's a non-stop decimal number and if it can't be converted, to fraction. So these are irrational numbers. So far so good?
Yeah.
Okay, good. So you know what are irrational numbers. So now let's talk about what is rational numbers. So under the rational number, you have integers. All right, and then you have fractions, and you have decimal number. So far so good?
Yeah.
Okay, so I think you have no problems understanding what are decimal numbers. Do you have problems understanding what are decimal numbers?
No.
Okay, so can I ask you, is 1.4 a decimal number?
Yeah.
Is 1.4123 a decimal number?
Yeah.
Then
Yes. Yeah.
yes or no?
Yeah.
Okay. Then can I ask you, then what about this 1.4123 should it be rational or irrational?
Irrational.
Correct. So this you shouldn't put it here. Even though it's decimal number, you should put it under the irrational number. Okay? So decimal number under the rational number is 1.4, 1.52. So that means all these decimal numbers, they are what? They are finite. Okay? Finite means it's not non-stop. It will stop somewhere. Okay? And then
Okay.
it can be expressed as a fraction. Okay?
Okay.
You can test 1.4. Can you convert?
Yeah.
So what is 1.4 into fraction? One point four into fraction, quick.
7/5.
Good. Okay, so 1.4 is 7/5. Alright? So
Yeah.
can you see that this is a rational number? Okay, because it can be expressed as a fraction. for irrational number, it can't be converted to fractions. Okay, so fractions,
Yeah.
I don't have to teach you what are fractions, like 1 over 2. Can you give me an example of fractions?
1/4.
1 over 4, yes, very good. So integers. So for integers, you have positive integers, you have 0, and then you also have negative integers. Alright? So positive integers like 1, negative integers like -3. So these are integers.
Okay.
Okay, so with this maths universe, like this chart, alright, so then with this understanding, I think you can answer the questions. You can understand question 2. Right? Okay, let's look at this. Minus 1.23. So number 1. Okay, let's find out all the irrational number first. Because I think the irrational numbers, so once you sort out the irrational numbers, then the rest are rational numbers. So can you ask yourself, negative 1.23, is it irrational?
No,
Why not?
because it's not a non-stop decimal.
Very good. So basically, it's finite. It will stop. And then some more, if you use this, you are going to it can be converted into a fraction, right? So this one is out for irrational. What about square root 2?
It's an irrational number
Why?
because it's a non-stop decimal.
And then can this be converted to a fraction? You need to test. You need to
No.
test both 1 and 2, okay?
No, it cannot be converted.
It cannot. Okay, so -2 is irrational number. Okay. 3. What about 3? What about 3? Is 3 a not irrational number?
No,
Why not?
because it's not a decimal, a
Oh.
non-stop decimal.
Very good. So 3 out. What about pi? Use your calculator.
Non-stop decimal.
Non-stop. Can it be converted to a fraction?
No.
So is it an irrational number? For pi.
Yeah.
Okay,
It's
good.
an irrational number.
Good. Okay, last one. 1 and 4 over 7.
It's a non-stop decimal but can be converted.
So irrational or
Rational.
is a rational, right? Because it fits the first requirement, but it fails the second requirement. So
Yeah.
not irrational. Okay, so out of these 5, right, for irrational numbers, you have square root 2. Where is square root 3? Where is square root 3? There is no square root 3. Look at your answer. There is no square root 3.
I wrote it wrong.
You're not supposed to make mistakes like this. You are in sec 2 already. Come on. By the way, what's your age?
13.
You are 13 already. 13, okay? 13 years of age. You're not supposed to make mistakes like this anymore. You have grown up a lot. Sec 2. Next year, Sec 3. O level is coming. And you still make this kind of mistake. Alright? I have lightened your workload a lot already. I asked you to do it on your this Chromebook. So you don't have to copy questions. And you're not supposed to copy wrongly. By the way, it's square root 2. Alright? So it's square root 2 and then 2. And pi. Correct. Okay, now, so since you already picked out all the irrational numbers, so now I think the question is pretty easy. So just get rid of the irrational numbers. So integers. So which one is integer here? Is this an integer? Minus 1.23? Integers are whole numbers.
No.
Okay? What did I say?
Integers are whole numbers.
Very good. So if you look at integers, right? Positive 1, 0, or negative 3. Okay? Integers are whole numbers. So negative 1.23, is this a whole number? It's not. This is not a whole number. So this should be under what? This should be under decimal number. This one. So it's not integer. So the only integer is 3. So far so good?
Yeah.
Okay, then with this understanding, you are more or less done already. Square root 2 pi out because they are irrational. So negative 1.23, is it a rational number? You just look at this. Let's look at this column. Can you focus on this column?
Yeah.
So negative 1.23, it falls under what? Integer, fraction, decimal numbers. Negative 1.23, it falls under?
Decimal?
Yes. Why is it decimal?
Because it can be converted.
Yes. Test out yourself.
Yeah.
Okay, good. What? So you get your, this is your rational number, minus 1.23. Next. Next. 3. Is it rational numbers?
Yeah.
It falls under?
The integer.
Very good. Done. 1 and 4 over 7. It falls under?
Fraction.
Very good. So it's a rational numbers. So next time when you do this kind of question, you know what you need to do? You need to draw this maths universe out. Okay?
Okay.
So basically this is your, this is so called your this maths universe should be inside your head. Okay? So once you put this math universe out, right, I think you just compare your this, not compare, you just ask yourself each number against this math universe. Then you can find out whether they are integers, rational numbers, and irrational numbers. Does it make sense?
Yeah.
Okay? Pretty easy. Alright? Next. Then arrange the above number in descending order. So it's descending order means big to small, right?
Yeah.
Alright? So this is 对 okay? Good. Okay, another way to arrange them in descending order, actually you should make use of the bigger sign instead of a comma. Can you see what I have written here? So basically you should do pi is bigger than 3, is bigger than no comma, okay?
Oh, okay.
1 and 4 over 7, and then square root 2, and then minus 1.23. Okay, you should do it this way, okay?
Yeah.
Alright, next. Okay, 这题 express 2160 as the product of prime factorization. Okay, so how many 2 you have? 1, 2, 3, 4, 4 2. Okay, very good. Then how many 5? 1 5. Then how many 3? Wait, are you supposed to write 3? I mean, are you supposed to write 1? What is, okay,
No.
prime factors. So what are the first few prime numbers? You have already written down, right?
Yeah.
Good. So when you end 3 here, are you supposed to continue?
No.
Why not?
Because 3 is already a prime number.
Correct. So basically you should stop here already. So I'm not supposed to see this. Alright?
Yeah.
Okay?
Okay.
So your answer should not have this one. So your answer should be this. Okay, you don't need to show this. So basically, prime factorization, this is the prime factorization. Index notation, this is the index notation. So this is index notation. This is prime factorization. So you just have to show this and this. Are you clear?
Yeah.
Okay. So when you do this, okay, you stop at prime number. So 3 is the prime number, so you stop here. Clear or not?
Yeah.
Okay, next it says the largest 3-digit number that is a factor of this 2160. So how you do this? So you just find the factor lah. So 2160, 1 times 2160. So 2 is, what is it? If you put 2, you will get 1080, right? If you put 3, you get what? 720, right? If you put 4, you will get 540, right? So if you do it this way, so which one is the largest 3-digit number?
540.
Huh? 540?
720.
Yeah. It should be 720. How come you did not show me the working? Where's your working? Where's your working?
I actually looked it from the graph, the working I did for A.
You mean here?
Yeah.
How do you find factor?
This question I asked like another teacher.
But how? No.
Because I didn't understand this question.
No. First thing first. How do you get the factors of this? Any idea? If I ask you, okay, let's say I give you 8. How do you find the factors of 8? Can you tell me factors of 8?
Factors of 8.
Yeah, here.
No.
I ask you to look at the screen.
1.
Why 1?
1 times 8.
Okay, good. Next.
2 times 4.
Next.
That's all.
That's all, right?
Yeah.
Then, if I ask you which one is the biggest factor among this?
8.
So the answer is 8, right? In this case?
Yeah.
Right? Okay, good. So same thing. If I ask you for the factor of 2160, right? Can you see?
Yeah.
So factor of 2160, are you supposed to use this method? Are you supposed to use this method?
Yeah.
Yeah, you are supposed to use this method to find factors. Once you get all the factors, then you ask yourself, among this, which one is the biggest 3-digit? Is it 540 or 720? Ask yourself.
720.
Yeah, then if I ask you instead of 3-digit, if I change the question to 4-digit, so what's the answer for 4-digit? Read from here.
160.
Yes, exactly. Why you need to ask another teacher? Of course, you can go ahead and ask another teacher, but I don't think you need to. Because you need to.
The last.
You mean this one? Part 2?
Yeah, then they explain everything.
Okay. In fact, part 2, probably you need to ask your teacher. But I'm asking you for part 1 only. How come you jump to part 2 already? I'm asking you part 2 only. Part 2, you're supposed to use this method, right?
Yeah.
Yeah. I'm not talking about part 2 yet. I'm talking about part 1. You don't jump to the next step. So are you clear how you should find the factor of 210 or any number, factor of any number?
Yeah.
Okay, good. So next, you are asked to find this is a perfect cube. Okay, good. So if you get this question, perfect cube, all you need to do, in fact, you have 2 to the power of 4, 3 to the power of 3, then 5, and then let me see what you have done. Okay, I'm not sure if you're this way. Okay, probably you have learned this way, but let me teach you my way of solving this question. Okay, so the smallest integer case such that 2160. So your 2160 is given by this 2 to the power of 4, 5, and then 3 to the power of 3. This is your 2160 in prime factorization. Okay?
Yeah.
So now you need to times a k, right? Can you see? It times a k, right? Yeah.
Yeah.
So it times a k such that it's a perfect cube. You know what's the meaning of perfect cube? So it can be cube rooted.
Like 2 times something.
It can be cube rooted. That's called perfect cube. Can you repeat? Perfect cube means it can be cube rooted.
Perfect cube means it can be cube rooted.
Okay, so if you write it out, so it should look like this. This one. So now you ask yourself, one by one. Okay, one by one. Start with the 2 first. Can you cube root this? 2 to the power of 4? You can test with your calculator. Perfect cube rooted, that means you end up with a whole number. Not
16.
Huh?
16.
I say cube root 2 to the power of 4. I circle already, right?
It's a decimal.
So cannot, right?
Yeah.
So when you cannot, so what you do if you cannot? That's why you need to give it. You need to put in. So you need to test. So this one cannot be cube rooted. So you give it a 2. So you have. Can you give? So I give it a 2. So can you use your calculator to test? After giving it 1, 2, can you cube root this thing? Use your calculator. Don't use your mental calculation.
It's still a decimal.
So give 1, 2 cannot. Let me give 1 more 2. Test. So I have given 2 2's into this one already. So can it be cube rooted now? Perfectly.
4.
Can, right?
Yeah.
So that means after giving it 2 2's, right? So the 2 to the power of 4 can be cube rooted, right? Okay?
Yeah.
Okay, good. So I'm done with the 2. So now go to the next one. So now what you need to do, you need to check for the 5. Can you cube root the 5? Can you cube root the 5?
5.
Can you cube root the 5 perfectly?
No.
No. Okay. Cannot. That means what you need to do. Just now we cannot cube root the 2. We give it 2, right?
Yeah.
So now we cannot cube root 5. So what we need to do? Huh?
Add another 5 inside.
Don't use the word add. Put. Okay.
Put.
Give it a 5. Now test. So when you give it a 5, you put an arrow below so that you know that, oh, the arrow one is the one I put in. So I put 1 5 into it. Can you cube root now perfectly?
No.
So cannot. So what you do next?
Put in another 5.
Put in another 5. Good. So when you put in another 5, put an arrow underneath so that you know you put in 5.
Yeah.
Good. Okay, good. So that means after putting in 2 5s, you can cube root the 5 already, right? Okay, next. The last one you need to take care of is the 3 to the power of 3. Can you see? Just now you have done for the 2 to the power of 4. You are done with the 5. Now you need to cube root the, can you cube root the 3 to the power of 3?
Three.
Yeah.
Yeah.
Can you?
Yeah.
Can. So that means basically can. So if you can, do you need to put in 3? It can be cube rooted perfectly. So do you need to put in 3 or not?
No.
Why not?
Because it already is like a perfect.
Correct. So if it's already, it can be cube rooted perfectly, you don't need to put in another 3, so you stop. So how many, so what you have put in? Can you see? You have put in 2 2s, right? And you have put in 2 5s, right?
Yeah.
So you times these you times these two things together. So if you times these two things together, you will get, so this is 2 times 2, 2 times 2 give you 4, right? And then 5 times 5 give you 5 times 5 give you
25.
Okay, so you have put in 4 times 25, so the answer is 100. So k equals to 100. Are you clear? So the whole thing is, just now you ask yourself, you put in 2 2s, right? Then after that you put in 2 5s, right? So you just times all these numbers that you put in. So if you times all these numbers that you put in, use your calculator, you will end up with 100. So the answer is 100. So same answer as your, I don't know who you asked, but same answer as your this. Are you clear?
Yeah.
Are you clear or not?
Yeah.
Okay, good. Next. Okay, this one I think is super easy because you just have to find the greatest difference. But first thing first, where is your working? Where is your working for the entire question? 在哪里? You copy from somewhere or copy from someone or what? Guess.
No.
Then where's your working?
Just compare like that.
There is no just compare like that. You have to do some working. You have to do some calculation. Even I need to do some calculation to tell myself which one is the answer. You don't compare, okay? You write down the answers. Write down your working. How many times we need to repeat? Okay? You must write workings. No working, you get penalized. So for this question, I think your answer is correct, but I want you to go back and show me the working.
Okay.
So next time when you do question, what you need to show? What you need to show next
Working.
time? Exactly. Always show your working. Okay, 这题 HCF. How do you find the HCF? They already give it to you. How do you find the HCF? Who teach you to do it this way? Who teach you to do it this way?
Oh yeah, this one is another question that I asked.
Ask who?
Another teacher.
You don't have to ask. By the way, you are in your holiday, right? How come you can ask teacher?
Because I have their phone number.
Oh, okay, good. Okay, so let me just teach you how you can do this question. Okay, so can you remember last time how we find HCF or not? Let's say I give you 20, I give you 40. How do you find the HCF? You do this, right?
Yeah.
Am I right? So,
Yeah.
which one give you the HCF? So HCF is equal to HCF for this. What's the answer?
20.
How do you get 20?
You times the 2,
Hmm.
2 times 2 times 5.
Correct. Then how do you get the LCM? So the HCF comes from the side numbers. So how do you get the LCM for this question? You don't give me the answer, I ask you how. I'm not asking you what. So tell me how.
You must take the 2 times 2 times 5 times 2.
对吗 Okay, times 2, sorry.
40.
So basically to find the LCM, so what you do, you get this 5, you times them all together, right?
Yeah.
Okay, good. So with this understanding, with this understanding, right? With this whole thing, right? With this whole thing, so in fact, you can recreate. So your job is to recreate these two into this format. I'm going to show you how. Okay, I'm going to show you how now. Let me erase it first. For this one, how many 5 you have? How many 2 you have? Sorry. Is it too blur?
On the top,
Yeah. Is it too blur for you to see?
5.
You have 5. You have 5 2. Okay, good. So you just need to recreate. So basically you have 5 2. 1 2 3 4 5. Okay, good. One more. How many 5 you have? How many 5 you have?
10.
10. Okay, good. 1 2 3 4 5 6 7 8 9 10. Okay, good. How many 11 you have?
1.
How many 13 you have?
2.
Okay, I have recreated this into this already. I mean, I have recreated the first one into this. Okay? Now, I need to recreate this. How many 2 you have?
3.
3. How many 5 you have?
1.
How many 11 you have?
1.
How many 17 you have?
3.
Now you ask yourself, how many 2 they share? This one have, so how many 2 they share? 1 2 3. So they share 3 2s, right? That means they both have 3 2s, right? Are you clear? So 3 2s. 3 2 means 2 to the power of 3. How many 5 they share? 1. So 5 to the power 1. How many 11 they share? 1 11.
Yeah.
How many 13 they share? No, nothing. How many 17 they share? No, nothing. So this is your HCF. You times them together. Can you see that my answer and your answer is the same?
Yeah.
So what's the technique to find HCF? You recreate them into this format first. Once you recreate them, you just ask yourself how many they share. So you just use the line to cross out. So you find that, oh, they share 3 2s, 1 5 and 1 11, and then you just times them together. Are you clear?
Yeah.
Okay, good. Now, how do you get the LCM? Okay, the LCM is very simple. The LCM is they already share the 2 to the power of 3, right? They already share the 5 to the power of 1. They already share the 11 to the power of 1. So you just have to times the rest. What is the rest? How many 5? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 to the power of 9. So how many 13? 2 13. How many 17? Okay, so the LCM, right, if you can notice, the LCM is always equals to the HCF times the rest. So this is the HCF, this is the rest. Are you clear now?
Yeah.
Okay, let me introduce you to the question just now. 20, 40. So can you see that this is 10, this is 20, this is 2, this is 5, 10, 5, 1 and 2. See, this is your HCF, right? 2 times 2 times 5, right?
Yeah.
Here, right? So how do you get the LCM? LCM equals to the HCF times the rest, right? Remember, LCM is always HCF times the rest. So what is your HCF? The HCF is this one, right? So it's 2 times 2 times 5. So what is the rest? 1 and 2. Are you clear?
Yeah.
Can you see now? LCM is always HCF times the times what?
Then the rest
Where do you get the rest?
from the other column.
Yep, from here, right? So similarly, if you go back to this question, just now I already do the HCF using the, I cross out. If you can see, I use the, hold on, let me just demonstrate to you how do you get the LCM. Okay, so all these lines, right? Okay, let me cross out again. So all these lines I cross out is the HCF, right? So the rest is, what's the rest? The rest is this, 2 to the power of 2. Yeah, I miss out the 2 to the power of 2, by the way. And then I still miss out the, let me use a different color. So all the cross out is the HCF, and now the rest is the square one. So the square one, this is 2 to the power of 2. This is 5 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 13 to the power of 2. This is 17 to the power of 3. So you just take the HCF, you times the rest. The rest is this. 2 to the power of 2, 5 to the power of 9, 13 to the power of 2, 17 to the power of 3. Are you clear?
Yeah.
Alright? So it's pretty easy. Okay, good. So now comes to the 8b. This is the question like just now. But over here it says this is, instead of cube root, this is square root. Can you see it's square root?
Yeah.
Okay, so how you do this question? We just make use of the work we have done just now. Let me just repeat it one more time. Okay, ask yourself. Do this one first. Can you square root the 2 to the power of 5 or not? Do it. Square root are not cube root.
No.
No. So what you do if no?
Put in another
Put
2.
in another 2. So put another 2. Can you cube root? Can you square root or not?
Yeah.
Okay, can already. So that means after putting in a 2, you can. Okay, now done. I do the 5 to the power of 10. Can you?
Yeah.
Can. So do you need to put in?
No.
Okay, good. No need. So I am going to do for the 11. Square root 11.
No.
So what you do? If no,
Put in another.
put in another 11. Yes. When you put in another 11, put an arrow below so that you know that later you look at it. Oh, I put in all these numbers. So after putting in the 11, can you?
No.
So putting another 11, you cannot square root.
Yeah.
You sure or not? Square root 11 times 11.
Oh yeah, can.
Can. Okay, so after putting in 111, can already. So now the last number 13. So square root 13 to the power of 2. Can you?
Yeah.
Okay, good. So if you look at all this, what you have put in. You look at my screen, what you have put in. You put in the 2 and
11.
11, right? So you
Yeah.
just times these two together. So you get,
22.
so 22 is the same as your answer. So now you know how you can get the K already?
Yeah.
So the K always come from what numbers you have put in, then you multiply them together. Are you clear?
Oh. Okay.
Are you clear?
Yeah.
Okay, good. 这一题 okay, very good. So in fact this question I think is super simple. You know why? So they ask you whether this makes sense or not, whether this chart is reasonable or not. In fact, you can quickly do it by using, you know what you are using? The technique is called, what you are using, by the way? Your answer is reasonable. I don't know, but let me ask. So can you see that 2 erasers at 49 cents, 6 pence at 1.95? Can you do it with a whole number 50 cents? So
What?
49 cents is very close to 50 cents, right?
Yeah.
They say without doing the actual calculation, you are doing actual calculation
estimate.
already. Yeah, estimate, yes. So instead of 49 cents, you just whole number it, so become 50 cents, easier, right?
Yeah.
So 2 times 50 cents is $1. So the eraser costs you $1. So now, instead of $1.95, can you convert this to $2? Right? 1.95. The closest is $2, right?
Yeah.
So you have 6 of them. So 6 of them is 12. Right?
Yeah.
So if you have $1, you have $12. So if you add up, you get 13. So in fact, 13 is a overestimate already. Overestimate. You know why is the overestimate? Because all your this 1.95 and then 49 you round up, right?
Yeah.
When you round up, you know what it means? What it means? It means you overestimate. Right? So when you round up, you already overestimate. So that means $13 is already overestimate. So now the shopper charge you 13.50 cents. So does it make sense or not? So basically, the shopper, did the shopper overcharge you or not?
No.
Did the shopkeeper overcharge you by charge
No.
you 13.50 cents?
No.
Why not? I thought $13 is already overestimate. So $13 is already overestimate. You 13.5, is it even more overestimate? Is it more overestimate or not?
Yeah.
Okay, do you agree your 49 cent, you round up, right? When you round up, what you mean? That means you overestimate. I ask you to look at the screen, right? Hello?
Yeah.
Okay. Let me erase this. Let me give you another example. $170 ice cream. Okay? You buy 3. Okay? You buy 3. Okay? You buy 3. And then the shopkeeper charge you $7. Is $7 reasonable? How you do? First,
170 change it to $2.
when you change it to $2, you round up or you round down?
Round up.
So you already round up. Round up means you already pay more already. Do you agree?
Yeah.
When you round up, right, that means you are already paying more. Understand? Understand?
Yeah.
So you 3 times the 2, you will get $6, right? This $6 is an overestimate or is an underestimate? This $6, you 3 times $2, so $6 is an overestimate or underestimate?
Overestimate.
Because it's overestimate because round up, you times the round up number, definitely is round up lah. I mean $6 is round up. That means more than you are supposed to pay. So that's called overestimate. Understand? So your $6 is already an overestimate. Then can I ask you, is $7 reasonable or not? If you get charged $7,
No.
why not?
Because $6 is overestimate.
Yeah, $6 is already overestimate. Then $7 is
$7 is like it's less of it.
huh?
$7 is like unreasonable price.
Why unreasonable? So if $6 is overestimate, your $7 is this overestimate. Does it make sense?
Yeah.
Or more than overestimate? You get the idea now?
Yeah.
Okay, so your this 13.5 here, your this 13.5, okay, by the way, just now we end up with how much? $1. Round up already, $1. Round up already, $12. So $13, I say, is already an overestimate, right?
Yeah.
So if $13 is an overestimate, your 13.5 is overestimate. So is it reasonable or not?
No.
Okay, so that means you get robbed already. Okay.
Yeah.
Okay, so it's not reasonable. So the answer is not reasonable. Because 13.5 is more than overestimate. That's the reason. Are you clear?
Yeah. Okay.
Okay, so that's how you can use approximation or this is called rounding off or estimation to answer such question. Okay?
Yeah.
Good. 为什么你这里 0.59 啊？
My zero. No, my handwriting.
Not handwriting, because you really use 0.59.
I wrote.
You're supposed to use 50 cent. 你 50 cent 在这里 then 你在这里你写 59 cent.
No, I think it's because my zero I read like 9 like that.
Wait,
Yeah.
you don't anyhow say. 0 and 9 is very different. You don't tell me 0 and 9 is the same thing. It can never be the same thing. Okay? So you copy wrongly again. Alright? Over here, you clearly write 9. This is a 9. This is not a 0. So once again, you copy wrongly. And by the way, you are already at Sec 2. I mean next week. Next week, you are going to Sec 2 already. And you still copy wrongly. Okay? You're not supposed to copy wrongly anymore. Are you clear?
Yeah.
Okay? Next. This one is very simple. Two significant figure. How do you get two significant figure? So this is correct. 1, 2. Okay, 很好. Did you ask anybody here for this question?
No.
Okay, 很好. Do it yourself. Okay, by the way, it says without the use of calculator. Did you ask anybody here? Wow,
No.
so many steps.
I
Also, okay,
finish the calculation first, then I check using the calculator.
If I'm not wrong, this answer is half leh. Because I did this question with my one of my students yesterday. But let me just do it together. So I do this first. So 1/3 plus minus is minus, so it's half. So you times 2 times 2, you times 3, you times 3. So this is 2, 6 minus 3 over 6. This is minus 1 over 7. Okay, good. Then I will do this part. Minus 1, 6. Then this becomes plus 1 over 6. Okay, very good. So this one is you times 6. Okay, 6. So this is 24. You times 4. You times 24. So you still minus 2 over 24. Then you divide by this. Divide by means times 6. Yeah, it should be half. 你这个错了. Here. For this one, right? For this one, right? Okay, this one is correct. So this part is correct. But the first part, right? You should end up with this. So I think you already jump step, right? That's why you are wrong. This part. So you have minus 24. Okay, let me just do this part only. This part you are wrong. So you have 6 times 1, 6 times 4. You have a minus sign in front. So you have plus 4 times 1, 4 times 6. So this one you get what? This one you get minus 6 over 24. This one you get plus 4 over 24. So if you do this, you get minus 2 over 24. So if you simplify, you get minus 1 over 12. Not half. Not minus half. You're supposed to get this for the first one. Okay? 呢？这里吗？你又抄错啊 ？Yes.
Where? What?
你又抄错了。Your this one is minus 1 over 12. But 为什么你去写 minus 1 over 2? Copy wrongly again. Okay? One assignment, copy wrongly 3 times. And some more you are already at Sec 2. You 有看到吗？
Yeah.
This one and this one. So when you copy wrongly, how can we help? 我们怎么帮你？啊 How can we help you if you copy wrongly? Hello. How to help you?
You can't?
We cannot.
It's my own mistake.
Yes. Okay. So never mind. So let me get this question into the... Okay, I think you might make a mistake here because we talk about what are... I'm talking about this question 1. We just talk about what are rational numbers, irrational numbers, prime number, perfect square, right? So now with the understanding, I think you can redo this question already. Okay, before you redo this question, what I need you to do is we go to the Jamboard. Let me just create a Jamboard. Let me create a Jamboard. Loading. Can you see the Jamboard already?
No. Not yet.
Not yet, hold on.
Yeah.
Good. So with the Jamboard, right, what I want you to do is this. Where's my Jamboard? Let me try to write on the Jamboard. Can you see? I have just scribbled. Yeah, okay, good. So let me just get the question to the Jamboard. 1.63. Okay, first, can you see my screen?
Yeah.
You are looking at the Jamboard or the screen?
I'm looking at the Jamboard.
Okay, good. Very good. 3 minus 4 square root 4 cube root 24. So the first question is irrational number. Okay, before you do the irrational number, I think, can you draw the maths universe here? Can you draw the math universe here? Then later we will talk about.
Me too.
Do I need to allow you to draw or something?
Yeah.
You request? Is it
Yeah,
like,
okay. It's in the email, yeah.
so you request already or not yet?
Yeah, because already.
So I need to allow, is it?
Yeah.
Okay, hold on. I'm using my phone to give you access. But surprisingly, they never prompt me right here to give you access. Very funny. Open. Yeah, I open already. Then send. Can? Yeah, person added. Can you?
Okay, wait. 没有 open 的。Yeah, okay.
Good, very good. Come. So draw the map. Okay, let me just write down the maths universe. Once you have written down this math universe, then only you can ask yourself against this maths universe. Okay, time for you to draw. Go. 这里啊，这里，这里。Here. Below. You just go ahead, do what you need to do, okay? Good. So under the irrational numbers, yeah. What are the two requirements? So 1 and 2. So what's the first requirement? Can you still remember? Can't be converted what? Some more leh. Can't be converted what? Here. Second requirement. 很好。By the way, it's integers. There is no R here. Okay, continue. This is your first one. Second one. So I use a plus to denote, to indicate another type of rational numbers. Fractions, very good. Next. Yeah. Go ahead, just use a plus. So actually before decimal, right, I think you should write finite lah, huh? Okay, so with this understanding, so basically with this maths universe, ask yourself 3. So 3 is which one? Where you put the 3?
Integer.
Yes. INT. What about negative 4?
Integer.
Very good. What about square root 4?
Integer.
Very good. What about this? Cube root 20?
Irrational.
IRR. What about 4?
Integer.
Very good. Okay? Simple, right?
Yeah.
Okay. Then among all these, right, which one is prime number?
3.
So first thing, before you write down the prime number, always write down the first few first. So can you write down the first few prime number? 来这里。Okay, good. So done. Good. So 3, 可以了。So 3 is one of them. Anything else?
No.
什么
No.
What about this square root 4?
Yeah.
Why?
Number.
Why yes?
Because it's a 2.
Correct. So you have to test. Alright. 可以吗
Yeah.
Okay, good. 可以了。So let me just stop share this one first. Go back to our. Okay, before we go to the second half, then let's take a brief 5-minute break. Come back, we're going to talk about the second homework.
Okay.
Alright? Okay, looks good. Okay, see you in a while.
Okay.
用什么跟他上课？
谷歌密。
谷歌密。
你们不用谷歌密啊？
拿过分。
今要谁的买我看。 Alright, I'm back. 回来了，回来了。Good. Let me present. Then this one. Can you see my screen? This is the second homework. Okay, so over here you are asked to write 140 as the product of its prime factors. So you divide by 2. 你看你又写的乱来 should be 70 here. You write until 76. Charmaine, you are sec 2 already, okay? We are not supposed to talk about handwriting anymore. Alright? Then after that you put a 5, you get 7. How come I still see 1? You already tell yourself 2, 3, 5, 7, 11 are prime numbers, right?
Yeah.
So where you stop? You stop at prime number. So 7 is already prime. Why you continue? Understand?
Yeah.
Okay, so this is the answer. Okay?
Okay.
And by the way, you are not supposed to show me this step, okay?
Okay.
Next. So divide by 2, divide by 2, divide by 2. No more this step. Okay? So how many 2 you have? Oh, actually you can also express it in this manner. Huh? Both are correct. You don't need to show me this. You can? How do you get the highest common factor? Here. Right?
Yeah.
How do you get the LCM? LCM is equal to highest common factor times the rest, right?
Yeah.
So what's your HCF? HCF is this one, no? Which is 2 times 2 times 3. What's the rest? 5 and 8. No? Does it make sense? This is the rest, right? This 2 is the rest. This one is your HCF. Right? So it's just HCF times the rest. Right?
Yeah.
Yeah. Okay, by the way, you don't have to do this part now. No need. I don't. How come you go and do this part? Can I ask? This part. Who teach you to do this part, by the way? Somebody else? Where you learn this from? This part.
I think you needed to
Some more?
simplify that to a prime number as well. So I went to do that part.
You can. You can, but do you need to?
No?
You don't need to. So you just stop here, then you just hit CF times the 5 times the 8. That's it. Can you see? Times the 5 times the 8. Because the 5 and the 8, they are the rest. So LCM is equal to HCF times the rest. The rest is 5 and 8 in this case. Are you clear?
Yeah.
Okay. 这题 how many 2? This part no need. How do you get the LCM? So you get this part first. This is the HCF, right?
Yeah.
So the rest 错了 no need. This part no need. You don't do extra thing, can?
Okay.
So no need this part. From here onwards no need. So this is your HCF. Then your HCF times the rest, which is 1 and 5. In fact, you don't need to times the 1, just times the 5. So I'm supposed to see this one, then correct. Okay?
Yeah.
Next. Product or power is prime factors. 这个是对的。Highest common factor, that means I just take this part. Highest common factor, once again, this part. Wrong. You can use your calculator, double check. Double check this.
Oh, it's 8.
Yes, the answer is 8. LCM, how do you find LCM? Just take the HCF, which is here. HCF times the rest. The rest is 3 and 8, right?
Yeah.
So it's 8 times 3 times 8. So it's 8 times 3 times 8, correct. Oh, by the way, how do you get 192? You just use a calculator, okay? Just punch all this into your calculator. Are you clear?
Okay.
Correct. This is your HCF. How do you get the LCM? HCF times the rest, 5 and 6. This is the... Okay, good. Okay, so basically all the questions are repeat of itself, right? So it's just more practice. Oh, by the way, not needed. Yeah, so I'm not going to go through the all this again because they are very similar. They are repeat of. They are basically more practice questions to you, I hope you can see. Okay, this one is more interesting. They say the highest common factor HCF are 2 numbers. So you
This one I asked from my teacher.
You don't have to ask. So the way you do it is the highest common factor, right, of 2 number. So the first number is x, the other number is y. So the highest common factor of these 2 is 3. So that means they have a 3 outside lah. Because anything here, right, you put here, they are your HCF, right? Yeah. You can give yourself a simple example, 20 and 10. So you put a 2 here, you get 10, you get 5. You put a 5, you get 2 and 1. So these are the HCF, right?
Yeah.
So that means your HCF, you put a 3 here. Okay? So the lowest common multiple of the 2 is 45, right? So that means your this one and this one and this one, they times together will give you 45. Okay? How do you get 45? 3 times 5 can give you 45. This is one possible answer. Right? Can you think of another possible answer? Can or cannot? No more already. This is the only possible. Okay? Does it make sense?
Yeah.
So they say write down 2 numbers that James could be thinking. So how do you get the x here? So it's 3 times the 3, so you get 9, right? How do you get the y here? 3 times the 5, 15. Okay? So the 2 numbers James are thinking, one of them is 9, the other one is 15. Does it make sense? This is one answer. Then of course another answer is 3 and 45. So there are multiple possible answers. So your teacher teach you this, okay, but they can be 9 and 15, right? I just show you, right? You understand this solution or not? Yes or no?
Yeah.
No, I don't think you know. Okay, never mind, let me just do it again. So you have 2 numbers, which you don't know, but you know that the HCF is 3, right? here. So you put the 3 here. Because anything here is called the HCF, right? Am I right? How come there's no response from you?
Yeah.
Okay, good. Then now they say the LCM is 45. So how do you get 45? This one times this one times this one will give you 45. So how do you get 45? 3 times 3 times 5 is 45, right? Do you agree
Yeah.
or not? This times together give you 45?
Yeah.
So once you get this, so how do you get this? The first number, 3 times 3, so it's 9. And then 3 times the 5 is 15. So the two numbers can be 9 and 15. One possible answers. Are you clear?
Yeah.
Okay? Good. Okay, good. So for the HCF and LCM, I think you have no problems. Okay? Because this is just a repeat. Okay, have you collected your this textbook?
Yeah.
Okay. Can you show me your? Do you have your workbook? What's the first chapter, by the way?
I do not know. It is outside.
I thought you already have your textbook.
Yeah, but I haven't looked at it.
So why then you buy it for what if you don't look at it? This shows your attitude towards your mathematics. Some of my other students, they are already not only they have looked at it, they are already doing questions inside. Can you?
Bring your assessment book.
Some more? What's that?
Because I'm doing the assessment book.
It's okay. So can you quickly go and take your textbook and get it right now? Okay, and read to me what is the first chapter, and then we will look at it.
Okay.
I'll give you a minute. Please go.
Okay.
Okay, so you are supposed to see my you are supposed to see the Jamboard, like a
Yeah.
whiteboard. Okay, good. So what's the first chapter?
Linear equations and inequalities in one variable.
Okay, good. So let me write it down first. So it's linear equation, right? Linear equation and
Yeah.
inequality.
Yeah.
That's your first chapter.
In one variable.
In one variable. That's your
Yeah.
first chapter. Okay, good. So today I'm going to talk about these two. Let's look at the first one, inequality. You know what's the meaning of inequality?
No.
I mean English. What's the
Oh.
meaning of inequality?
English.
Yes. Not equal. Let's say, how come you are so rich, I'm so poor? Right?
Yeah.
Yeah. So that's called inequality. Okay. So how come some countries, they don't have enough food to eat? Then how come in Singapore we have too much food to eat until we need to throw away our food. Okay, so that's the meaning
Yeah.
of inequality in English. Not equal. Right? So can I give you some examples of inequality? So number one, in inequality, so how do you know whether it is called an inequality? So you will see signs like this. So this is called the bigger sign. This is called the smaller sign. This is called the bigger and equal sign. So this is called the smaller and equal sign. So all these are inequality signs. So far so good?
Yeah.
Very good. So I'm going to give you some examples. You are supposed to see the next blank page.
Yeah.
Okay, good. So 3 and 2. So what sign you put here?
The bigger sign.
Very good. So what do you put here?
The smaller sign.
Very good. So what do you put here? You can use your calculator.
The equal sign.
Very good. So is this an inequality?
No,
Why not?
because it's equal.
Very good. So this is not an inequality. So this is not an inequality. Okay, so if this is not an inequality, this is a equation. Are you clear?
Yeah.
Or this is an equality. Alright? Okay? Okay, good.
Yeah.
So I have demonstrated to you what are some examples of simple inequality, and then differentiate your this inequality from this. Yeah, differentiate your this inequality from this not inequality. Alright? Next. So what if I give you this? So I'm going to give you some English statement. I have more than $2. How do you express this? So let's say I have is X. So more than $2. So what do you think? What you put here? What sign you put here? X is the money I have. So what sign you put here?
The more sign.
More than, right?
Yeah.
So how do you justify? So let's say I put the bigger sign here. So if I put the bigger sign here, right? What it means is X is $3. It can be, oh okay, cannot use is. So the meaning of this, right? Okay, let's look at the English statement first. So when I say I have more than $2, so can I ask you how much I have? Do you know how much do I have?
No,
Why not?
because it's an X. We only know that yeah, more than $2.
Yeah. So that means there is no specific, there is no there is no one specific answer, right?
Yeah.
So this means you have multiple answers. So I can have $3, I can have 2.5, I can have 12. As long as I have more than 2, they are acceptable. Am I right? Am I right?
Yeah.
Okay, so that's the meaning of this statement. I have more than $2. So if I use, this is the English statement. This is the mathematics. So if you are given the English statement, you use the mathematic to represent, you are supposed to use this. Are you clear?
Yeah.
Okay, good. So what if I show you this now? X is smaller than $20. So X is and X is a positive number. So what is X? So what's the smallest positive number? Hello? What's the smallest possible number? Zero or one? Smallest possible number. Hello? Smallest possible positive number. Quick, zero or one? Or how do you decide?
One.
One, yes. So is 1 smaller than 20? Is 1 smaller than 20?
Yeah.
Good. Is 2 smaller than 20? Is 2 smaller than 20?
Yeah.
Okay, good. So you need to write down all possible answers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Is 20 smaller than 20? Hmm?
18.
20. Is 20 smaller than 20?
It's equal.
Is equal. So it's not smaller. So 20 is not there. So if they ask you what is X in this case, these are the answers. All of them. Are you clear?
Yeah.
Okay. So that's how this is a very basic question about inequality. Next part. Okay, next part. So what if I give you this? X is smaller than 1 plus 2x. Then how do you do this question? Before you do this question, I want to ask you how you do this kind of question first. How do you do this kind of question first? Do you have any idea how you do this kind of question?
No.
Okay, good. So you need to learn how to solve this question first. Okay? So let's do a simple one first. By the way, this kind of question is called linear equation. Okay? So if I have 2 is equal to 1 plus x, how do you solve this kind of question first? So you need to find x equals to something, right? So you need to find this
Yeah.
x, right? So how do you find x? So x is equal to So x is equal to 什么？ What are you doing?
Charging money.
Oh. So how do you find x? Give yourself a simple example. So give yourself a plus example. 3 is equal to 1 plus 2. So in this case, you need to find what? X is your 2 here, right?
2.
So 2 is equal to what? From here.
3 minus 1.
Okay, so similarly, x is equal to?
2 minus 1.
Good. So 2 minus 1 is equal to?
1.
Good. So x is equal to 1. Are you clear?
Yeah.
Okay, I'm going to give you a few. So if you don't know how to do it, just give yourself a simple example. You learn it for the times, right? Can you remember? The 6 is equal to 2 times 3. Remember? And then 2 is equal to 6 divided by 3, right? Can you remember this or not? Can you remember this simple example?
Yeah.
Okay, good. So I'm going to give you another question. You're going to do it on the spot. Okay? Yep. Do it. 这里 You can give yourself a simple example on the right so that it guides you. 快 You don't need to ask for access, right? I think you are there already.
Well,
Yeah, you are there already. Yeah. Sorry. Okay, good. Yeah, go ahead. Quick one. How come you do the below one first?
oh,
I mean, you can lah, but I don't know why. Oh, by the way, before, okay, I don't know, okay, if you need an example to help you, you better give yourself a simple example here.
okay.
Okay? Before you make a mistake, you better give yourself a simple example here. Then you know whether it's minus or times or divide or plus.
Okay.
You didn't give yourself a simple example, huh?
Yeah, I wrote the 3x first.
Oh, okay. You should give yourself a simple example first. By the way, when you give yourself a simple example, you should give yourself a different numbers example. 3 is equal to? Alright, looks good. It's a plus, so you give yourself a plus example. Okay, so based on this example, so 3x is equal to, and you can use your calculator, by the way. You are allowed to use a calculator. By the way, you should know what the question wants you to find x. Huh? So how do you get x? Show me the step. Huh? Actually, you are using proportionality here. Can you see?
Oh.
Alright? Alright? 对吗? You divide by a 3, you get x. Therefore,
that's a decimal.
yep, it's okay. So, okay, you have your calculator. So, you can give me a decimal number, or you can give me a fraction. You can give me a mixed number. So, which number you are supposed to show me? Okay, you should know which number you should show me. Are you supposed to show me this? Are you supposed to show me a round off number? You have your calculator with you. Why you show this answer? Why this is the final answer instead of 6.3? 为什么?
It's like a round off number, and
So the final answer must be round off or not round off?
not.
Yeah, should be most exact. Okay, next question. Quick. By the way, you don't write the 3x first because sometimes it might not be 3x comes first. You always give yourself a simple example first. Let the simple example guide you. Don't blindly write down 3x. It might not be 3x. Okay?
Okay.
Give yourself a simple example in this. By the way, this is a subtraction. Give yourself a subtraction example. Okay? This is the subtraction example. Sorry. This one. You already have the subtraction example here already. Right? So you can make use of the example of above. So you don't have to redo. So 1 is equal to? What's this? Still to think so much. You only have a 2 and 3 for you to play with. Okay? Quick one. So similarly, which one is the 3? Which one is the 12? I mean, which one is the 3? Which one is the 2? Don't anyhow. Match. Can you match? You don't anyhow, okay? Must match. 2 is your 20. 3 is your 12. If you have a pencil, you should use a pencil. So now you can use your calculator. So you are supposed to find x, yes. Correct. Okay? So this is how you solve for x. Okay? Next. What if you have this? Instead of the equal sign, now is this smaller. You do the same. You do the same thing. Give yourself a simple example. 2 is equal to 3 minus 1. So 1 is equal to 3 minus 2, right?
Yeah.
So write the 3x here. Continue. Match. Okay, continue. Not yet, not yet. 3x. 3x is here, so 3x equals to minus 8. So x is equal to yeah. Okay, if you look at this, I never used the equal sign here, right? I used the smaller sign here, right? So what you do, you replace the equal sign with the smaller sign. So that's your answer for this question. Are you clear?
Yeah.
Are you clear?
Oh, yeah.
Okay? Are you clear now?
Yeah.
What about above? 这题
Yeah.
21 equal to 2 plus 3x. Okay. 21. Instead of equal, I use 2 plus 3x. So you give yourself a simple example here. Go ahead. Continue. Do the same for this. So instead of equal sign, you don't write equal sign, okay? Okay, I realized there is something I need to teach you before you can do this. Okay, it doesn't work this time. Okay, never mind. Let me just teach you another way. Okay, so if you have, so if you have this question, let me just change the question. So for this question, right? Okay, just now what I teach you is, can you stop writing? So just now what I teach you to do this is you just write the simple example, right? And then 1 is equal to 3 minus 2. So therefore 2x is equal to 21 minus 3. So 2x is equal to 18. So x is equal to divide by 2, then divide by 2. So you get 9. So this is one method. Okay? This is method 1. Right? And you have no problem. So what if I don't want you to use this method? I'm going to teach you another method. Because I find that method 1 cannot work with inequality. So what I'm going to teach you now is very simple. Can you see you have a 21 here, you have a 2x, and then you have a plus 3 here?
Yeah.
Okay, good. So now your job is to underline the terms first. Okay? So I think you have no problem underlining the terms. Okay? Because we have learned this last time. So this is one of the term, 21, 2x, and then plus 3. Am I right? Okay?
Yeah.
So, by the way, I want to underline the similar term. So, plus 3 and 21, they are similar because they are both numbers, right? The 2x is not number, so I use a straight line. Are you clear?
Yeah.
And then the number, I use wavy line. Are you clear?
Yeah.
Okay, good. So now the question to you is, can you see that I have a plus 3 here? I have a plus 3 here. So if I have a plus 3 here, I can actually move it. I can move it to the other side of the equal sign. Okay? So if you move this, so let's say I copy the equal sign here. So if I move the plus 3 to the other side, so my 21 is still 21. Can you see 21 is still 21?
Yeah.
I mean 21 is still on the left. Okay, so basically this is the equal sign. This is called the left hand side of the equal sign. This is called the right hand side of the equal sign. Alright? So what I have done is My 21 is still on the left hand side, so I just copy it down. Can you see I copy it down?
Yeah.
Okay, copy down, no change. But now I have moved the plus 3 from the right hand side to the left hand side. So plus 3, you move it over. This is called move over. When you move over, you need to change the sign. So plus 3, you change the sign, it becomes minus 3. So this is gone. Are you clear? So
Yeah.
once you move the plus 3 to the other side, you change the sign. So once you move the minus 3 over already, what is on the right hand side now? What's on the right hand side now? You have the 2x left, right?
Yeah.
So once you have the 2x left, continue. So equal sign, 21 minus 3 is 18, 2x. So you need to find x, so divide by 2. So divide by 2. So 9 is equal to x. So when 9 is equal to x, x equals to 9. Are you clear? So this is method 2. So what I have done is I use the move over change sign method. Okay? Let me give you another example. I'm going to use move over change sign. Okay? So first thing, underline the term for me first. Like, go ahead. Help me out. Underline the term using wavy line and then straight line, yes. The 3 or minus 3? Okay, good. So once you have underlined the terms, so what can you do? So can you see that 21 and minus 3, they are the same, right? They are both numbers, right? Hello? They are both numbers, right?
Yeah.
So if they are both numbers, you should put all the numbers together. So that means if you want to put all the numbers together, so most likely, so how do you make it together? So you are going to bring this over to this side, right?
Yeah.
So what did I say? The rule is move over. What's the next statement? Change sign.
Yeah.
Can you repeat? Move over, change sign.
Move over, change sign.
Good. So what do you end up with? Can you do the next step? You copy the 21 down, up, minus 3 become minus 3. What do you say? What do you say?
Change sign.
Yes. So move over, change sign. Can you tell yourself one more time?
Move over, change sign.
Good. So minus 3 becomes equal to 3. From minus, you change to minus. Opposite of minus is?
Plus.
Yes, that's called change sign. Minus and equal, they are not related at all. Okay, becomes plus. Good. So you already moved the minus 3 over already. So you end up with, can you see you end up with these two?
Yeah.
So you are having 24 equals to 2x. So you divide by 2, then you divide by 2. So you have 12. Are you clear?
Yeah.
You move, change sign. Move over, change sign. One more before we end the lesson. What about this question? Underline the term first. So can you see your minus 3 and 21, they are numbers, right?
Yeah.
So what you do?
You place them together.
Yeah. So how you put them together?
Move and change the sign.
Yeah, you move which one? You move
21.
You move the 21 or you move the -3? Which one is easier to move?
21.
So if you move the 21, you will end up with what? Is this easier? Oh, so you need to change the sign. Is this easier?
No.
Not easier. So don't move the 21. Then move the -3. Because once you move the -3, right? I think you can see, right?
Yeah.
You move the -3. So can you do it? You move the -3, it becomes? No, wait, wrong. Can you see? You move the -3 to this side, right? Can you see the arrow?
Yeah.
So -3 erase. So when you move the -3 over, it becomes what? -3 becomes? Move over, what's the next statement?
Change sign.
So -3 becomes?
Plus
Plus what?
3.
Good. So this is what you end up with. Are you clear? So what's the next step? Can you do the next step? Continue from here. Continue from here. Quick one. So you end up with 2x equal to 21 plus 3. Good.
No.
Continue. X is equal to? Oh yeah, you simplify first, yeah. Yes. Okay, so x is equal to 12. Okay, one more. Okay, what you do? Underline similar term first. What are you waiting for? Underline them. Okay, yeah, with the equal sign, with the minus sign. Okay, good. So what can you see? You have 2x. I mean, you have 2 with x, and then you have the 12, right? So what you want to do? You want to put the x together, right?
Yeah.
How?
Switch position.
Switch what? Show me the arrow. Show me the move over. I did not teach you to switch position. I teach you to move over, right? Move over and change sign. You move which one? Show me. Circle the one that you want to move. Circle first. Yes. And then where you move? Move to where? Arrow it. Wait. After the X or on top of the X?
After the X.
Then you better show after the X. Okay, very good. So probably you want to hold on. Probably you want to adjust the space a little bit. Okay, so minus 2x you move over become what? Can you write it here? It becomes what? Minus 2x you move over become plus 2x. Very good. So you move over already, erase. So you end up with this. Yes, correct. Continue. Very good. So x is equal to, yep. Very good. Correct. This is the way. So move over, change sign. Okay, very good. Correct. So going forward, I'm going to give you, okay, so what I need you to do, please take a photo of the questions at the back of your chapter 1. Then I will pick some questions and then assign those questions as homework for our upcoming lesson.
Okay.
Alright? Can? So go back and watch this recorded video, especially the last part. How do you move over, change sign? Okay, so for this, you move over the x. Can you see? For this, you move over the x. Then for the previous question, you move over the number. Okay, so you can either move over the number or you can move over the x. But ultimately, you just need to group the same thing together. Okay? When you move over, remember to change sign. Okay? Minus change to plus. Plus change to minus. Can or not?
Okay.
Okay? So, any other question for me?
No.
Okay, if not, then we can end the lesson today. Okay? So, remember to take a picture of the questions at the back of your chapter 1, and then I will assign you the question. Can you do it by tonight?
Yeah.
Please do it by tonight. Then I will assign you the question before Wednesday. Alright? Okay, see you. Bye bye.
Bye.
Take care.